Okay, now we will be moving to our next major topic. I think it will take about 2 weeks to complete, but it is one of the very critical topics in object-oriented programming, and it is operator overloading. Okay, so you see, when we started our discussion in the first couple of weeks, we dedicated them mostly to the revision of some basic concepts from programming like functions, pointers, and towards the end of week number 2, we started with objects and classes, right? So we spend some time in understanding what is a class, what is an object, what is private, what is public, why we have data as private, why we mostly keep functions public, what is a constructor, what is parameterized constructor, right? And then once we had this base knowledge, we applied it to develop some classes, right? So whenever we are discussing a concept, so I told you that I will introduce the concept with the simplest possible example, and mostly when we were looking at the first example of a new concept, I always use the class point, right? And then once I had some, you can say, feedback that, okay, some sort of understanding has been developed, then we applied the same concept to some real world problem. Like, so then we saw the next topic, which was composition, because previously, whatever programs we were making, we were only making a single class, right? But with composition, there's a concept of reusing the existing classes and using a has a relationship, right? So we today, as well as in the last week, we had seen examples where how we can reuse existing classes and we can make our life easier. So now with that preamble, we are in a position to go to this next topic, which is called operator overloading. And I think this is the most important topic if we see the first 8 weeks of the semester, right? So I think this is the most critical one. So I would request an extra attention from you because this is something very important, right? So what we'll see in this lecture, I'll introduce you what operator overloading is, right? So that would be just a conceptual introduction, and then we'll see the motivation that why we need it. Okay, because you can write a program without operator overloading, it will work, right? But why we need it, right? Just like you can write a program with constructor, but we make constructor to make our life easy. Okay, then we'll talk about operators in which we'll see different arithmetic operators, like plus, minus, multiply, or increment, which can be both binary or unary operator. And then we'll see relational operators like less than, greater than, and so on. So when we'll be doing operator overloading, there are actually 3 different ways when you can do that. Okay, I have not told you what it is, right? But I'm just introducing you that what we'll see. So we can do operator overloading using member function. Now, what is a member function? Member function means a function which is part of a class. Then we will study this concept using non-member function, means not part of a class, okay, which is like a global standalone function. And the third thing, which we will not study in this discussion, but maybe we'll come back to this after 2 or 3 weeks, which is friend functions, right? So for the time being, you can ignore this third one. You can focus only on 2. Number 1 is member function. Number 2 is non-member function, right? So this is what we plan to do. Okay. So now, what actually operator overloading is? Operator overloading in simplest possible words is a concept that if you implement, it allows you to use operators with objects of our classes, right? If you remember our previous discussion, we have been saying repeatedly that you cannot use operators with user-defined data type. When I say user-defined data type, it could be a structure, it could be a class, right? So previously, we have been dealing with this class point. It can be a class, it can be a structure, and so on, right? So we say, okay, you are allowed to write a statement like this, which is the assignment operator, right? But you cannot write, say, P1 plus P2. This will not work. You cannot write, I just told you, C out P1, okay? Because we are not allowed to use operators with objects of our own classes. So presently, we have been managing things, right? For example, if we are not allowed C out P1, what we did, we had a way around, we made a function print. Okay, and whenever I wanted to display a point, I used to call this function, right? Means we were doing our job, but in a different way. Similarly, since we were not able to use the plus operator, but we still were able to add 2 points. If you remember, we had done something like P3 is P1 dot add P2, something like that, okay? So we were still doing our job, but we were doing it with functions. Okay, now we'll try to do the same job, but this time rather than doing the job with the function, we'll try to use operators as much as possible, right? So again, this is the same old class. I just put it in the slides for completeness, right? Data members, a constructor, and to get function, right? Nothing else. So it's a very basic class which we see almost in every lecture. Okay. So as we told you that you see when we were adding 2 points, we made a function add in the point class, right? So if you remember what happened, what used to happen was that P1 and P2, right? They are added. It means the x coordinate are added. 4 plus 2 is 6 and 4 plus 3 is 7. Both of these are added and the answer of this goes to this third object P3, right? This we were doing. But if I ask you that do the same operation but using this operator, then you know very well that this will not work. Why this will not work? Number one, no operator other than assignment operator can be used with user-defined classes, right? So that's why we said this will not work. But after today's discussion, we'll be introducing this concept of operator overloading, which will make this a legal statement, right? It means we will be able to do that. Of course, the functionality would stay the same, means you will have exactly or more or less similar functionality which you had written in the add function. But now, rather than calling it add, you will be using this operator. Okay. Now, again, motivation that why we need to do this. For example, if I can write p1.add p2, and this is also doing the same thing, right? Both actually will be adding 2 points. So without operator overloading, we use this function. With operator overloading, we can use this, right? So again, operator overloading will simplify your program. It will make your program more readable, right? Because you see plus is something standard. Whenever you see plus, you know 2 things are added. When you are making function, right? So you see, if I'm making function, I can call it add. If you are making function, you can call it sum. Someone else can call it add points. Okay. So you see, there is no uniformity, right? This is not standardized. You are free to give any name to the function, right? Still, we are giving some meaningful name, but some of the programmers might not even give these meaningful names, right? Even if they are meaningful, then every programmer will give a name what they like. Add some, add 2 points, add point 1, point 2, anything, right? So when you see that function or you have to call that function, you don't know, or unless you see the class, you don't know what is the function to add, what is the function to subtract, right? If you are subtracting, whether the name is sub or subtract or difference or what, unless you see the header file of that class. But if you see this operator plus, you instantly know, okay, 2 things are added. If you see this operator minus, you instantly know 2 things are being subtracted. You don't need to memorize any names of the functions, that for subtraction, this was the function, for addition, this was the function, and so on for all the other operators, right? This is the main motivation of operator overloading, that just like we use operators with our basic data types, when we are using them with objects of our classes, our code is more readable, more simplified, and anyone going through the code can easily judge that what we are doing, what our intention is by looking at those operators, right? Otherwise, what you can do with operator overloading, you can also do that with functions, right? Means only the code will stay the same. The way you use it, only that will change, right? Okay. Now, before looking at operator overloading for objects, let's first go back to the basic data types. Okay. And maybe I can explain it maybe on the board so we have some more details, right? So I think we did this discussion in one of the earlier weeks as well, but let's again do it. Suppose I have 3 integers a, b, and c. You can initialize them. Okay, I'm not doing that. And here you have float like a, b, c. And then you can initialize these 3 variables, okay? And here I write c is a plus b, and here also I write c is a plus b. Whenever you have to add 2 things, you use this plus symbol or plus operator, right? And you don't care how they are added at the back end, right? If you add 2 and 3, you expect 5 as an answer. If you add 2.5 and 3.5, you expect 6 as an answer, okay? But you see, if you go back and suppose A is 2 and B is 3. So how is integer represented in the memory? Maybe in a binary form. So this is 8 bits, so 0, 0, 0. So this is actually 2, okay? And what is 3? 3 is like this, which is 3. You will add them together, right? So you will get 101, which is actually 5. On the other hand, suppose A is 456.34 and B is say 56.79. How real numbers, or we should not call them real numbers, maybe how floats are represented in the memory, right? So they are not represented like integers. They are represented in a different way. And if you remember arithmetic of some school level arithmetic book, you must have seen the scientific notation of representing number. For example, this number can be written as 4.5634 into 10 raised to power 2. Okay. Similarly, this 56.79, it is actually 5.679 into 10 raised to power 1, and so on, right? So you represent floats using mantissa and exponent, okay? So this is the exponential part and this is the mantissa part, okay? So the idea is that when two numbers are added, your variables are actually in the memory, okay? This is A, B, C. So in the memory, you have 2, 3, and some garbage here. When you write A plus B, you remember that in your processor, there's something which is called ALU, arithmetic logic unit. So your data from memory goes to ALU, it is added, and then it comes back to memory, which is stored in variable C. So the conclusion is that integers are added in a different way because they are represented differently. Floats are added in a different way, right? Now just imagine a situation where you have some symbol to add integers and maybe some other symbol. I don't know what to draw. Maybe this symbol for float. And then maybe for double, you have some other symbol. Okay, I don't know what to draw. Maybe this one, not this one. Maybe this. Okay, so just imagine a situation where to add two integers, you are doing this, A plus B. To add two floats, you have a different symbol. To add two doubles, you have a different symbol, and so on for every data type. So you see, you would not be able to remember all of these. This is for one operator, for addition. Same thing for subtraction, multiplication, right? That would make your life very difficult. So luckily, we don't have to bother. When I have to add two basic data types, I don't care A and B are integers, float, one integer, one float, one character, one integer, both doubles, whatever the combination is. I just use this symbol and I know it will add two things. Okay. So in other words, for the basic data type, some sort of operator overloading is already done, right? You have already seen function overloading, where same function is, you can say, doing different or taking different arguments, right? You have to add two numbers or three numbers. You can use function overloading where name of the function is same, but the input to the function is different. So it is a related concept that you see plus is adding two things irrespective of they are integers or float or doubles. So you see it looks like similar to function overloading, but since there is no function but an operator, so we are calling it operator overloading. Overloading means same thing is doing multiple jobs. Although the task is the same, that you have to add two things, but sometimes two integers, sometimes two floats, sometimes two double. So that's why we are using the term overloading, just related with function overloading, where same function is actually doing or accepting multiple types of or multiple number of arguments, right? So it's more or less the similar concept. But this, we are talking about basic data types. For the user-defined data types, this still is not true. Okay, so when we say the plus operator for the built-in data types, it is already overloaded. Means you can use it with integers, you can use it with float. There is no problem with that, right? And what is our objective now? That we should be able to use this operator with our own objects of our own classes as well, right? So we'll come back to this example in a while, but just a quick revisit of what different operators you have in C++, right? We see the first category of operator, they are unary operator. Unary operator means that they take a single operand. What does that mean? For example, if I write not x, so this is actually operator, and this is operand. Operand means the variable on which you are applying that operator, right? You must have seen this operator increment, which can be pre-increment or post-increment. Similarly, there is a version which is like decrement, which can be pre or post and so on, right? So all of these operators, they are taking a single operand and they are called unary operators. We have another category of operators, which is binary operator, right? So for example, when you are adding two things, so this is your operator, this is your operand 1, which is on the left side, and on the right side you have your operand 2, right? Similarly, subtraction, multiplication, or even you can have arithmetic operators or relational operators, right? Relational operators for comparison. So they are also binary operators because they are taking two operands, right? So there's also a ternary operator in C++, but we'll not be covering that in operator overloading, right? We'll be limiting our discussion to unary and binary operators, right? So now with that discussion, maybe we can shift to the code mode and we can see our first example, that how we can use operators with objects of our classes, right? And as we always do, the first example we'll do with point class, and then we'll change our class to see some other examples, okay? So let me just only write data, no functions, so that because you see it in almost every lecture, so I'll just write data so that I can refer to it. So int x, int y, and in public you will have some functions. Okay. Now let's come to the main and see what we want to do so that we can do it better. So this is our main, and where I have a point which is 2, 3, and another point which is say 4, 5, and then a third point. And what we want to do, we want to make this a legal statement. Presently it is not legal, but we want to do this, right? So this is our objective. So as I told you, if you want to do operator overloading, okay, so in this example, what is our objective? Our objective is to overload this plus operator. So overload this plus operator. It means every operator has to be overloaded separately. If I want plus, I will have to do something. If I want subtraction, I will have to do something else, and so on for every operator, right? So every operator has to be overloaded separately. It is not possible that you will do some magic and every operator which you use with integers will also be applicable to point, right? This will not happen. You will have to do it separately for each of the operators. Now, when we do operator overloading, what we do actually at the back end, we make a function. Okay, we'll make a function. Now, where do we make this function? We have three choices. Rather, we just stick to two choices for the time being. We can make this function inside the class, which is the point class, or we can make it a global function. So in this example, since we are looking at this for the first time, let's forget the option number 2, global function. Let's discuss the first option only, that whenever we will make the function, we are making it inside the class. Or in other words, I can say we are doing operator overloading using a member function, because member function is a part of class, right? So what we are trying to do, we are trying to overload the plus operator. I told you, if you have to overload an operator, you make a function. Where are we making that function? We are making that function inside the class, because in the first example, we are doing operator overloading using member function. Now, the most important thing is what would be the name of that function? You see, when you make a function, you can give it any name. You have choice, F1, F2, add, subtract, anything. But with operator overloading, you have to follow certain rules when you are naming the function. It means you do not have that much liberty now. You have a standard way of naming the function or giving a name to the function when you are doing operator overloading. And what is that convention? Okay, for the timing, I say, okay, return type is void. Let's forget about the arguments. We are just talking about name of the function. Okay, so I will make a function. I don't care what is here. I don't care what is return type. For the name of the function, you have to use the keyword, which is operator. Operator is a keyword in C++. So you will write operator and which operator you want to overload. I want to overload plus, okay, which is just the symbol is like that. So I will put plus here. Now this thing which I have written in blue, this is just your name of function, which is a standard way. And what is that standard way? Operator, keyword, followed by the symbol of the operator which you want to overload. Now, if I ask you overload the multiplication, so what would be the name of that function? Operator, multiplication is this symbol. So this is the name of the function to overload the multiplication operator. Similarly, you can do it for every operator. This will be for minus. Similarly, you can have divide, mod, anything, right? So in summary, when we want to overload an operator, we make a function. Presently, we are making that function inside the class. When we are choosing the name of the function, here we don't have a choice. Name of the function is keyword operator followed by the symbol of the operator we want to overload, right? And now what will happen? Whenever someone will write a statement P1 plus P2, this function will be called. This actually will happen. Okay, well, I'll write the body, I'll discuss the arguments later on, right? But presently, from a high level conceptual perspective, whenever now if you have made a function operator plus, whenever someone writes P1 plus P2, this function will be called. This is what happens. So you see, actually at the back end, you are making a function. Previously also you were making an add function. But simply by giving a standard name to that function without changing anything in the code, now you would be able to write P1 plus P2, and at the back end, this function will be called. Right now, what would be the argument? What would be the return type that we discussed, right? So before overloading this operator, let me rewrite the example that we did in week number 4, I think, when we were adding 2 points using the add function. Okay, so it means I will not be using operator. I will first be calling a member function, which we have previously done. I will just repeat it, and then we will convert it, you can say, or extend it to the operator overloading. Okay, so previously you have already seen this thing. P3 is P1 dot add P2. Okay, and let me also write the body of this function because this is important. So what we did here was that we made a member function which returns a point. The name of the function is add, which takes point, say, A. And when we were writing the body of the function, we say, okay, this is my point, which is my result. The last statement in this function would be return result. Okay. And in between, what we did was when we were calling that function, I keep telling you again and again what is in the argument P2. This P2 actually comes in this A. And since you are calling this function for P1, so when you write P1 dot add, if I write X here and Y here, they are X and Y of P1. Okay, because the function is called for object P1. So using the same concept, it means I can write X plus A dot X plus A dot Y. Okay, this is the example we have already done. I'm just repeating it. So A is actually P2, and this X is actually, which is in red, is X of P1. So you are adding X components of P1 and P2, Y components of P1 and P2, and you are copying them in result.x and result.y. Okay, so this was a function we made previously when we were trying to add 2 points using a member function. Okay. Now what I will do, instead of this add function, now I will simply give a different name to this function. Okay, let's keep it here. So I'm saying keep everything same, just give a different name to the function. Okay, so I'm just copy pasting this function, but only changing the name of the function. So instead of calling it add, I'm calling it operator plus, and rest everything you will notice not does not change. Okay, so here I will write point result, and then result dot x is x plus a dot x, result dot y is x plus, sorry, not xy, let me just correct it, is y plus a dot y, and then I say return result, and the class ends here. Okay, now you compare this function and this function, which I am highlighting. Okay, exactly same thing. The only difference is here I am calling it add, and here I have changed the name of the function. Okay, now add we have already discussed. Now let's see what happens when I write this in the main. Now when you write this, okay, what will happen? Whatever is on the right side, P2 is actually going to this A, which was happening here as well with the function. Okay, and whatever is on the left side, the function is called for object P1. So it means when I'm writing X and Y, these X and Y, they actually belong to P1. So you see exactly same thing is happening, but just another way is I'm writing P1 plus P2. So P2 is passed as an argument. It goes to A, just like it was happening in the add function. And the function is called for object P1. So I already have X and Y of P1. I add X coordinates together, Y coordinates together, and I return the answer. So now you see, I am allowed to use this operator with point class, but actually I am making a function. So it's only at the front end that anyone who is using the point class, now he or she will have the flexibility that they can write P1 plus P2. Although at the back end we have made the function, right? Because it cannot be automatic. We know how to add 2 points, whether we want to add X and Y, or we want to add only X or only Y, or it could be something else depending upon a class, right? So this is, you can say, how operator overloading is working. And by the way, I'm just telling you, although you should not do that. If you write P3 P1 dot, means you call this function like this. Okay, instead of using plus operator, you call it just P1 dot and name of this function, and like this is syntax wise also legal. But you see, it does not make sense to do this, because if we have to do this, then we could have kept it add function. There was no need of this. Although if you write in your program, this is a legal statement, there's no problem with that. Okay, but if you have to write this and you want to simplify your program, then there's no need of going into all this pain. Then we can have simply use the add function, which was already there, right? So syntax wise this is okay, but practically no one will ever do that. Okay, so I think I should make this program, show you the output, and then maybe we can discuss. Okay, so just give me some time so that I can make this program. Actually, we already have the class point. Okay, so I will just extend the same class and add functionality in it. Okay, so first let me make the previous one, which was the add function. Okay, so I write point add, say point A. Okay, and within this function, I say point result, return result, and I say result dot x is x plus a dot x. Result dot y is y plus a dot y. This is what was happening previously. Okay. Now what I will do, I will simply copy paste it. Okay, I'm just copying it, pasting it, and what I'm doing, I will change the name of this function to operator plus. You see nothing else has changed. Exactly the same code, but instead of calling it add, we have given it a special name, which is name of the function, sorry, the operator keyword and the symbol of the operator which we want to overload. Okay, now let's try to call this function. Maybe I can just get rid of this flight class and so on. Yeah. Okay, so in the main now what we do, maybe we take 2 points, point P1, which is 2, 3, point P2, which is 4, 5, okay, and another point P3. So you see when I write P3 is P1 plus P2. Now it is not giving me any error. Okay, previously when we were writing, it was giving us an error. Okay, and now we don't have any error. Rather, let me just cut it and paste it close to the point class so that you can actually see it. Yeah. Okay. So whenever you write this statement P1 plus P2, the function which we have made, this function will be called, right? So this statement will actually call this function, and P2, which is on the right side, it goes as input to A. P1, which is on the left side, so it means these X and Y actually belong to P1. So just like you were doing previously, you add them together, and to convince ourselves that this is working, maybe we can print P3. So I write P3 dot print point. Okay, so it should be 4 plus 2 is 6 and 5 plus 3 is 8. So it should give us 6, 8 as an output, right? So let me just run this program and show you the output. So you see, we have added P1 and P2 together, X coordinate and Y coordinate, and we get 6, 8 as the output. Okay, so let's go back to this program. And if you want to convince yourself that by writing this, actually this is called, okay, so you can do, for example, you can write something here. So this function is called, okay, so that you are convinced. Now you see, even if you don't add them together, you don't do anything. You just want to convince yourself that writing P1 plus P2 will call this function. So you can simply write a cout statement here, run this program without even adding two numbers, and you will see this printed on the screen. So you'll be convinced that this function is actually called. And now you see, once you can overload one operator, it's so easy. You can overload any operator, right? For example, if I have to also use the subtraction operator, I will simply copy this function. I will paste it, and instead of plus, I'll be using minus. Okay, so I say, okay, I simply, because it's fairly simple to subtract, it is very similar to addition. So when you want to overload subtraction, you have a function operator followed by this symbol for the subtraction operator, and then exactly the same logic, but instead of adding 2 points, we are subtracting 2 points, right? And similarly, you can also overload other arithmetic operators, right? For the time being, we are only focusing on arithmetic operators. So just forget about other operators. We'll come back to that later, right? So now you have this first example on operator overloading. Now we can spare some time on discussion. Okay, so maybe now we see a different example, right? Other than point, although it is very similar to point. I'm sure all of you must be familiar with complex numbers. Right? This is again a very good example if you are trying to study operator overloading. So you see what is a complex number, say like 2 plus 3 iota, 4 plus 5 iota, and so on, right? It has a real part and it has an imaginary part, okay? So you see, actually it is very similar to a point class. When you will make a class for complex number, it has two parts actually. So I make a class complex number, and it has two parts. One is real and the other is imaginary. You see, it is exactly or more or less very similar to XY. Instead of calling XY, we are calling them real and imaginary, right? Some of the students, they find it a bit confusing that where this iota will go, right? Do I need a character to store it? So actually you don't need to store this iota, right? When I am writing on the paper, I write 2 plus 3 iota so that anyone who reads, he or she knows that this 3 is actually the imaginary part. Because if I only write 2 plus 3, they will think it's 5. Okay. But when you are storing in a computer program, you have a different variable for 2 and a different variable for 3. So 2 is stored in this variable real, 3 is stored in this variable imaginary. So that's why please don't think that you have to store this iota. Okay, this iota is only when we are writing by hand, maybe, so that if someone reads the expression, they know that this 3 is actually not integer, it is not the real part, it is the imaginary part. So otherwise, if you see, this example is exactly, or this class is very much same. Previously we were calling them x, y, but by calling them real and imaginary, which are just variable name, you can actually do many things with complex numbers. Okay, so you see, just like we overloaded the plus operator for point, we can also add two complex numbers. And when you add two complex number, what happens is that the real part is added with the real part and imaginary part is added with the imaginary part, which was actually happening in case of point as well. X are added together and Y are added together, right? So it means using exactly the same piece of code, you can make a class which is complex number. You can make different complex number like this, C1, C2, and maybe C3. And using a very similar program, you can actually add complex numbers as well. Okay. So similarly, you can subtract them, you can multiply them, you can divide them, or whatever you want to do. Okay. So you can extend the point class to this. One additional piece of information that we'll do maybe tomorrow is that you see, suppose I have a point. This is my point P, which is say 4, 4. So it means this point is 4 and this point is 4. And there can also be a situation if I ask you, okay, what is the length of this line, which is going from 0, 0 to 4, 4. Okay, so you know maybe it is 4 square plus 4 square distance formula under root. So this will give you the length of the line. So you can actually tell me how far this point P is from the origin. Now, maybe the examples we'll do tomorrow, we'll try to do such things using operators. Okay, that okay, what is the magnitude or how far this point is from the origin? So you know the distance formula, but instead of making a function, we'll be trying to do it with operator overloading. And but what it will change tomorrow is that when you are adding two numbers, okay, you have two operands. But if I ask you find the distance of this point from origin, there is only one point. Okay, there is no other second point. So it means that maybe tomorrow we'll be talking about unary operators, which take only one operand, right? If I ask you there is a single point, how far it is from the origin? So you see there is no other point, only a single point, for which we'll be discussing some unary operators, right? But if I ask you to add, you always add two things, right? If I ask you add two and I don't tell you the second number, you cannot give me the answer. So the another why I'm telling you this is because the second property, the first property I told you was you cannot change the precedence. The second property is you cannot change the number of operands when you are doing operator overloading. What does it mean? If you are overloading plus, you must add two things. You cannot write x plus. This would be illegal. Okay, so the two properties we have seen, what are those? The first property was you cannot change the precedence of the operators, means what is evaluated first, multiplication, addition, and so on. And the second thing related to this is you cannot change the number of operands. Means if it's a plus, there must be two operands. If it's a multiplication, there must be two operands. If it is plus plus, there must be only one operand, right? So maybe we have discussed this one in detail. We'll see some more examples of the second property in our next session, right?